Oxidation properties of hydrogen peroxide. Hi, hello. This is your lucky sir. Hydrogen peroxide is a very special compound where oxygen oxidation state is -1. Hydrogen peroxide changes to water where oxidation state of oxygen is -2. -1 to -2 means it is decrease in oxidation state. Decrease in oxidation state is called a reduction. That means hydrogen peroxide is undergoing reduction. When a compound undergoes reduction, it is an oxidizing agent. So, in all oxidation reactions of hydrogen peroxide, the product will be water. Similarly, H2O2 can be converted to O2 where oxidation state changes to 0. That means increase in oxidation state. Increase in oxidation number is called, this is known as oxidation. When it undergoes oxidation, it is a reducing agent. So hydrogen peroxide can function like oxidizing agent and reducing agent. In this session, in this class, we will discuss about the hydrogen peroxide oxidation properties. That means oxidizing agent, it is going to function. So in all these reactions, we can see water is going to be the product, except one reaction. That reaction also I will tell you. So how it happens? Hydrogen peroxide is a good oxidizing agent in acid medium as well as alkaline medium. Acid medium and alkaline medium, both medium, it is going to happen. How? H2O2 plus 2H plus 2 electrons gives rise to 2H2O. H plus means this we are doing in acid medium. Then H2O2 plus 2 electrons gives rise to 2 OH minus. This is in basic medium. You can say this is the basic reaction. Okay, in acidic medium, how it is happening. In basic medium, how it is happening. So overall, you can say hydrogen peroxide gives rise to water and a nascent oxygen type. Because of this oxygen, it is going to be a very good oxidizing agent. It is easy way to remember. Hydrogen peroxide gives you oxygen. See how the reactions are going to be. Very interesting. I will give you some examples also, daily life examples also, where we are going to use the first one. In acid medium, I give you the balanced equations only so that it will be easy for you. First one, lead sulfide, PbS is converted to PbSO4. 4H2O2 gives rise to PbSO4. Lead sulfate plus water. Black color lead sulfide will become white color lead sulfate. Black color converts into white color. Black color lead sulfide is converted to white color lead sulfate. Lead sulfide converted to lead sulfate. Here oxidation state of sulfur is -2. Here oxidation state of sulfur is +6. Very simple. Okay, now, and remember, in your board examination, if you are going to write 2 oxidation reactions, 2 reduction reactions, you can go with this reaction. This is the easiest one. Second one, these are the standard reactions, you can say. It oxidizes nitrites. Nitrites means NO2 minus, 2 nitrates, NO3 minus. Here oxidation state is +3. In this case, the oxidation state of nitrogen is going to be +5. From +3 to +5, increase in oxidation state. Example, if you want, NaNO2 plus H2O2, NaNO3 plus H2O. Very simple reaction. Black color lead sulfide to white color lead sulfate. Sodium nitrite to sodium nitrate. Nitrite salts are converted to nitrates. Similarly, you can expect for sulfides also. Sulfides are SO3 minus 2 converted to SO4 minus 2. sulfites to sulfates, where the oxidation state of sulfur changes from +4 to +6. I am giving you with all details, so just look at this very carefully. Example same, sodium sulfite will take Na2SO3 plus hydrogen peroxide will give you sodium sulfate Na2SO4 plus water. Sulfite converted to sulfate. Simple. Then arsenides to arsenates. Arsenides to arsenates. It means lower oxidation state. 8 means higher oxidation state. You can take the simple example Na3ASO3 plus hydrogen peroxide gives rise to Na3ASO4 plus H2O. Same thing here, oxidation state is +3. Here oxidation state of arsenic is +5. Increase in oxidation state is oxidation. So here you can see that oxidation. Then potassium iodide. Potassium iodide is oxidized to I2. I minus is converted to I2. The reaction is very simple. 2Ki plus H2SO4. In the presence of acid medium, we are saying H2O2 gives rise to K2SO4 plus I2 plus H2O. H2O is common. I minus, here it is I minus, -1 oxidation state, here it is 0 oxidation state. Increase in oxidation state is oxidation. So sulfites to sulfates, arsenides to arsenates, iodide to iodine. Okay, now already we were discussing about 2 reactions, that is lead sulfide to lead sulfate, nitrites to nitrates. 3 here. So 5 reactions over. And for board examination, 2 enough. But we are taking the maximum possibilities so that you can remember all this. H2S, hydrogen sulfide, is oxidized to sulfur. For this reaction, you can take H2S plus H2O2 gives rise to 2H2O plus sulfur. Oxidation state change from -2 to 0. -2 to 0 means it is increase in oxidation state. Then ferrous sulfate is oxidized to ferric sulfate. FeSO4, ferrous sulfate, is oxidized to Fe2SO4 taken thrice, ferric sulfate, where oxidation state of iron changes from +2 to +3. The reaction will be 2FeSO4 plus H2SO4 plus H2O2. Here it turns into Fe2SO4 taken thrice, ferric sulfate plus water. It's balanced, you can check. Ferrous sulfate is oxidized to ferric sulfate. Oxidation state of iron changes from +2 to +3. Increase in oxidation state is oxidation. Then one more reaction will take. H2O2 oxidizes potassium ferrocyanide to potassium ferricyanide. K4FeCN6. It is also very similar, where oxidation state of iron is +2, change it to K3FeCN6. Potassium ferricyanide, where oxidation state of iron is +3, +2 to +3. Potassium ferrocyanide to potassium ferricyanide. The balanced equation 2K4FeCN6. There is no need to search for any balanced equation. I am giving you the balanced equation also. In presence of acid medium, H2SO4, hydrogen peroxide is the oxidizing agent. Make this 2K3FeCN6. Potassium ferrocyanide is converted to potassium ferricyanide plus K2SO4 plus H2. Potassium ferrocyanide is changed to potassium ferricyanide. Oxidation state change from +2 to +3. Very, very important reaction. In entrance examination, there is no need to check with the balanced equations and all. Just remember ferrous to ferric, potassium ferrocyanide to potassium ferricyanide. Like this, if you remember, that's enough. And one very special reaction is, it is known as Fenton's reagent also. H2O2 plus FeSO4. This combination is called Fenton's reagent. I think you remember organic chemistry points. It is used for conversion of primary alcohols into aldehydes, secondary alcohols into ketones. And very special reaction is when you take benzene with H2O2, very special reaction it is going to form OH. For balancing purpose I am writing here 2. And here you can notice there is no water is not formed here. I told you in the beginning only, I'll give one special reaction where water is not formed, and this is that one. Benzene when treated with H2O2, it forms a phenol. This is phenol. Very special reaction. Then it can convert mercury Hg plus H2O2 to HgO, mercuric oxide plus H2O. Mercury is converted to mercuric oxide. In the same way, NH2OH is called hydroxylamine. Hydroxylamine is converted to, when you are treating with hydrogen peroxide, it is converted to HNO3. HNO3 is nitric acid. You can check the balanced equation. It is forming H2O here. It is very special reaction. Hydroxylamine is oxidized to HNO3. Very, very special reaction. And N2H4 is hydrazine. When you are taking hydrazine, this hydrazine is oxidized to N2H4 is N, it is converted to N2. And balancing purpose I am taking here 2, and it is 4H2. All these reactions are happening in acid medium. Hydroxylamine is to nitric acid. Remember, this will be your entrance question. And hydrazine is converted to nitrogen. These kind of questions will be generally asked in your institution questions and all. Very special, because hydrogen peroxide in NCERT we don't have so many equations. I am giving you the maximum possible equations from all different books that we have. Coming to alkaline medium. Till now whatever we are discussing, all those are oxidation properties in acidic medium. We will discuss few reactions in alkaline medium too. In alkaline medium, it is going to convert HCHO, formaldehyde. This formaldehyde when treated with hydrogen peroxide H2O2, it forms formic acid. Formaldehyde is converted to formic acid. Formaldehyde to formic acid, one very, very special reaction you can remember. And this takes place in the presence of pyrogallon. I think you remember what is pyrogallon. Pyrogallon we discuss in hydrogen and its compound lesson. Pyrogallon is particularly used to absorb excess of oxygen. Okay, and this we discuss. Even excess of oxygen means oxygen should be taken. So noble gases lesson also we discuss. 1, 2, 3 trihydroxybenzene is pyrogallon. OH, OH, OH. This is pyrogallon. Pyrogallon. In phenols lesson also you can see the structure. Pyrogallon, 1, 2, 3 trihydroxybenzene. Then chromium hydroxide, CrOH taken thrice, where oxidation state of chromium is +3. This chromium hydroxide is converted to CrO4 -2, where oxidation state of chromium is going to be +6. +3 to +6 increase in oxidation state, but it happens in the presence of basic medium. A balanced equation you can see, chromium hydroxide in the presence of base means I am taking here sodium hydroxide with hydrogen peroxide H2O2. It is going to oxidize this to Na2CrO4, sodium chromate along with water. It's a balanced equation, but remember this point, chromium hydroxide is converted to chromate, where oxidation state changes from +3 to +6. And we can take even manganese sulfate also. MnSO4 is manganese sulfate, where oxidation state of manganese is going to be +2. It is converted to +4 manganese dioxide, black color powder, H2O2 and sodium hydroxide. It is converted to MnO2, manganese dioxide, where oxidation state of manganese is +4. Increase in oxidation state is oxidation plus Na2SO4. As usual, we will be getting here water. MnSO4 is converted to MnO2. Change in oxidation state is from +2 to +4 in the presence of basic medium. And ferrous Fe+2 can be converted to ferric in the presence of basic medium 2. H2O2 gives rise to 2Fe+3 plus 2OH minus. You can take even this reaction also. So in the presence of basic medium, we have taken some reactions. We'll discuss about reduction properties of hydrogen peroxide in another video, right? Just to go through with this again. Signing off, Lucky Sir.